Perpetuity, what does this mean? It means to infinity. Do we have any application with this? Yes, we have a lot of application with this. All of the charity projects, we use this perpetuity to judge this charity project or to fund this charity project. For the mosques, for the churches, for the charity hospitals, for 57 all of that we use perpetuity to take decision in regards to this entities or this organization, as I will show you after that. And even we use this perpetuity to judge the performance of or the value of the stocks, since we have this idea that this stock is going to remain in the market forever. The company will remain, and you can sell your investment in the company or keep your investment in the company. It's your decision, but the company will remain. Okay, which we call it an ongoing concern of the company. Okay, now to calculate the future value of a single amount, as I told you, you are in need for three things. You are in need for the amount. You are in need for the interest rate that is going to be compounded at, and number of periods. Okay, using an equation. This is the equation. It's what? Future value equal present value multiplied by 1 plus interest rate to power n, which is the number of periods. N could be 3 years, as here, could be 5 years, could be 10 years. It's up to you, up to your investment horizon. Okay. This is the thing. So future value, present value, interest, annual interest rate, and number of periods to be used. If we look for this example, what is the future value of 800 placed in a saving account, paying 6% interest compounded annually, and you are wanted to know what is the future value of this 800. The future value of this 800 is going to be future value after 5 years is going to be 800. This is the present value multiplied by 1 plus 60%. This is the interest rate to power 5. This is the number of periods. This is 800 multiplied by 1.338 is going to give you $1,070.40. By the way, we call this future value interest factor. We call this future value interest factor. So we have another way to calculate the future value of this 800. Instead of going through the equation, we can use tables. We have time tables. These tables will give you the future value interest factor to be multiplied by the present value to know what is the future value of this amount of money if invested at that interest rate for this number of periods. Number of periods, not number of years. Okay, again and again and again and again. Don't make this mistake that you mix between periods and years. If it's paid semi-annual for 5 years, number of years is going to be 10. And the interest rate, the annual interest rate, 8% is going to be 6% per 6 months. We are going to see that. So, if you are going to use the table, I will show you the tables now. The future value interest factor here, which is what? Which is 1 plus the interest rate to power n. We have the schedule for this, all of this interest rate for different number of periods, as you will see now. Here we go. Here is the time table, but you have to take care. We have 4 timetables, okay? 2 of them for the present value and another 2 for the future value. Future value of a single amount and future value of annuity, okay? Future value of single amount and future value of annuity, present value of single amount and future value of annuity. And as I told you, there is no timetable for the mixed stream of cash flow. With the mixed stream of cash flow, we consider it as single amount, okay? Each one of them we consider as a single amount and we calculate the future value of it. How to use these tables? Here, as you see here, table E1, future value interest factor for $1 to be received one time, compounded at key interest rate for n periods. $1 is not annuity. This is a single amount. If we are talking about annuity here, $1 annuity. As you see here, $1 annuity. This is in table E2. So what we have here, this is the interest rate that you are going to compound at, and this is the number of periods that you are going to compound for. Okay, so in our example, we're talking about 6% and 5 periods. So here is the 6%. Here is the 6%, you go down, and here is the 5 periods, you go to the right, and the intersection between 6% and 5, this is the future value interest factor at 6% interest rate and 5 periods, which is the same as we saw in the presentation here. This is the future value interest factor, which is, let's go here. This is the 1.338, which is the same as I showed to you here, which is here, 1.338, 6% and 5. Okay, so it's much more easier to use this timetable. It's going to be provided in the exam. It's your choice to use the equation or to use the timetable, but I'm not happy to tell you that you will not be able to use financial calculator to calculate future value, present value of single amount of mixed stream or whatever, because for now this is introductory course. It's not you are not required to come to the course with your financial calculator, but I promise you, if you go to finance major, you will be using the financial calculator until the last course in finance. Everything and a lot of problems will be explained using financial calculator, which is the most advanced tool to calculate all of the problem for time value of money, bond valuation, stock valuation, fixed income security analysis, derivatives, merger and acquisitions, capital budgeting, a lot of courses to be taught using financial calculator, and it's very easy to be used. So if I will see you in the finance major, definitely I will teach you how to use the financial calculator to calculate the present value and the future value. What if this compounding is going to be for more than annual? What does this mean? It means that it's going to be compounded for more than 1 year. I will give you your interest after 6 months. The 12% will not be paid at the end of the year. The 12% is going to be paid twice, 6% and 6%. 6% after 6 months and 6% after another 6 months. So 6 plus 6 is 12%. But you have the opportunity to reinvest the 6% that you received after 6 months for another 6 months, which will make the future value of semi-annual higher than the future value of annual. What if you will receive your money after 3 months? You will start to make money after 3 months, not after 6 months. So the future value of quarterly paid interest rate is going to be higher than the future value of semi-annual paid interest rate. What if you will receive your interest after 1 month? So you will start to reinvest after 1 month. Definitely the future value of monthly compounding is going to be higher than the future value of quarterly compound interest rate, higher than the semi-annual compound interest rate, and the lowest is the annual interest rate, which we call it nominal interest rate. Sometimes we call it the stated annual interest rate. Most of the interest rates that we give you in any problem in life, this is stated annual or nominal interest rate. Okay? So this is what is going to take us to another concept. It's not about nominal interest rate now, it's about effective interest rate. It is not about 12% annual interest rate. What if this 12% will be paid in semi-annual, quarterly, monthly fashion? What is the effective annual interest rate? So we are going to go from the concept of nominal interest rate to the concept of the effective annual interest rate. Okay, nominal interest rate or stated annual interest rate. This is the interest rate written in the contract between you and the bank that you are going to receive 12% annually. But how this is going to be paid? Annually, semi-annually, quarterly, monthly, or what? This, if you are going to receive it for more than once per year, it means you are going to go from nominal to effective. The effective, this is the true annual interest rate. We call it effective annual interest rate. This is the actual interest rate that you are going to receive. How to do that? This is very easy. You divide by number of periods, you multiply it years by number of periods, okay? If you divide by 2, you multiply by 2. If you divide by 4, you multiply by 4, as we will see now. Let's take this example, much more easier than the example. Much more easier than the example that we have in the lecture notes, but you have the lecture notes as well, and you can look at this example. What if nominal interest rate equal 12%? We want to calculate effective annual rate. We want to calculate the effective annual rate of what? Of semi-annual pay. It's paid semi-annually. The effective annual rate of semi-annual pay is going to be 1 plus 12%. It's a semi-annual. The year has 2 halves. So divided by 2 to power 2 minus 1. And effective annual rate, quarterly pay, is going to be 1 plus 12% divided by 4 to power 4 minus 1 equal. Effective annual rate of monthly pay equal 1 plus 12% divided by 12 to power 12 minus 1 equal how much? Let's look at this one. Let me bring my financial calculator, which I promise you